Hello everyone, we're about to start classes and I am pretty happy with some of the videos that I made in spring of 2020, so I want to do a few for the start of the semester. Can't promise that I'm always going to have these for you, but this will be a way that I review the notes before class and that you can review them afterwards. I wouldn't recommend watching these videos instead of going to class, but they're a way for you to study later on. So our objective of the class is going to be to model dynamic systems to predict their responses to various inputs and control their outputs. So I didn't feel like writing all the text down while pressing play, so here's our objective. We're going to model dynamic systems, predict their responses, various inputs, and control their outputs. And what we might ask is, what is a system and what makes it dynamic? So in class, we're going to talk about what are several different types of systems. And you might say things like weather systems, digestive systems, mechanical, electrical, hydraulic systems, solar systems. We'll find out what you've said. And our definition is going to be that a system is a collection of components That's messy writing. Well, that's what you get for free stuff. Systems, collective components that work together in non-trivial ways in order to map inputs from external environment to outputs. Okay, so I don't like using DCS for defining definitions. I think last time I would upload things with everything typed. I'll have to go back to that for when I'm writing a lot of words. But this is the first one. I want to encourage you to go to class, so if this first video isn't great, I think it will survive. But let's say that we have a system, and if you imagine any of those systems we talked about before, digestive system, weather system, electrical system, mechanical system, it's always going to be a simplification in terms of how we represent it. But we're going to consider that each system, in the way that it interacts with the environment, would be based off of inputs and outputs, and we can mathematically determine how it's going to work. So it works together in non-trivial ways, which means that for given inputs, we can predict what happens with their outputs. And we're going to have two types of systems. So we have static systems, and in a static system, then the system is going to be a function of its inputs, and the inputs are going to affect the outputs. So we have output is only a function of the current inputs, and if we have a dynamic system, we have that the output is a function of the current inputs as well as past inputs. So we have inputs and past inputs. Be dynamic. Okay, and you can see I'm pretty rusty. Again, I want to encourage you to come to class. So we're going to say that that's our definition of systems. Pretty hot mess for a first video. But let's go ahead and call that a day.